Okay, we're going to look at something called finding the distance between a point and a line. And so the two I'm going to choose here is -2, -1, and y is equal to x minus 3. In order to do that, I'll just show you a quick sketch of what this would look like. -2, -1 would be right about here. And y is equal to x minus 3. Well, let's just sketch that. We're going to go down to minus 3 here, and as a slope of 1. So there's the line. Y is equal to, there's the line, y is equal to x minus 3. And the distance would be the perpendicular distance right here. So it always makes a right angle, so it would be that distance right here. We're looking at what is that distance. Well, in order to do that, okay, you have to do a couple things. One is you're going to have to find out what the slope of this line is. And you'll notice that the slope of this line right here, cutting through the other one, the slope would have to be the negative reciprocal, because it would have to be perpendicular to the first line. And so I know here that the slope of this line right here, okay, the slope of that line would be equal to, let's see here, well, if this one is -1, or pardon me, 1, then my slope here of the perpendicular line has to be equal to -1, or the reciprocal. And so now I have the slope of that line. The second thing I'm going to need, okay, is I need to figure out what this intersection is right there. In order to do that, I'm going to need the equation of this line. Well, the equation of this line is simply going to be y minus, and of course I know a point on it already. It's -1, so that would be y plus 1 is equal to -1 x, and then minus 2, which would be x plus 2. At this point here, I have my point slope formula, but I want to move this into, so I can find this intercept right here. And so in order to do that, I'm going to keep moving this around and just write that y is equal to, if I rearrange this, that will be -2. And of course I can take the -1 to the other side. And so what's going to happen here is this will be y is equal to -x minus 3. So this line is perpendicular to that line. It turns out, in fact, I can already see where it's going to cross. It's going to cross at -3. But in order to check where it's going to cross, I can set these two equations equal, this one and this one, because the equation of that line right here is y is equal to -x minus 3, and this one. So where I set them equal, that's where they're going to intersect. Now, in order to do that, I'm going to get here that x minus 3, that's this graph, has to be equal to the other graph, which is -x minus 3. And when I move this around here, what I'm going to get is I'm going to get 2x is equal to 0, or just that x is equal to 0. In which case I could plug it back in to get y, and if I plug in x equals 0, I would get y is equal to -3. So the point 0, -3 must be the intersection. Why is that important? Well, because now I have 2 points and I want to find the distance between them. So we can just use the distance formula. And so just a reminder, that point there was -2, -1 coming from here. And I'm just going to scroll down a bit. So now I'm going to use the distance formula between these 2 points, in which case you're going to get d is equal to the square root of x2 minus x1, which is going to be 0 plus 2 squared. Okay, that's 0 minus 2 squared. And the other point here is going to be -3 plus 1 squared. Let's keep rearranging this. This will become 2 squared, which will become 4. And this will become -2 squared, or another 4. And so the distance between these is just the root of 8, and I'm finished. Okay, there's the distance between a point and a line. And you follow that similar process regardless of the point or the line.